What if everything you were taught about who the original Israelites were is only half the story? DNA just found the other half, buried in ancient bones. In May 2020, a team of geneticists and archaeologists published a study that would redefine the starting point for understanding ancient identity in the southern Levant. Working across 5 archaeological sites: Tel Megiddo, Tel Abel Beth Makkah, Hazor, Yehud, and Baka. They extracted and sequenced DNA from the remains of 73 individuals, each buried between the Middle Bronze Age and the Iron Age. The results pointed to an unexpected level of genetic uniformity. Despite the political boundaries and city-state rivalries of the era, these people, commonly labeled as Canaanites, shared a consistent genetic profile across hundreds of kilometers and more than 1,000 years. The genetic signatures revealed a blend that was neither isolated nor simple. Around 55 to 70% of the ancestry traced back to local Neolithic farmers, the earliest agriculturalists who had settled the region millennia before. The remaining 30 to 45% reflected a wave of migration from the northeast, linked to populations from the Zagros Mountains of Iran and the Caucasus. This two-source model, confirmed through both principal component analysis and admixture modeling, provided a clear baseline. The Bronze Age Levant was already a product of mixing, not a genetic island. Researchers initially expected that the constant movement along trade routes, the rise and fall of city-states, and the presence of foreign rulers would have produced a patchwork of genetic profiles. Instead, the data showed a surprisingly cohesive gene pool. The homogeneity was so strong that only a handful of later individuals stood out as recent migrants, while the rest fit the established pattern. This discovery matters because it sets the reference point for every later claim about Hebrews, Israelites, and Jews. The Canaanite gene pool was not erased by conquest or replaced by newcomers. Instead, it persisted, forming the core ancestry of the region's populations. Later biblical identities, whether tribal, political, or religious, would emerge from within this shared genetic landscape. When comparing ancient DNA to modern populations, scientists found that more than half of the ancestry of today's Jews, Palestinians, and Lebanese can be traced directly back to these Bronze Age Canaanites. The story of ancient Israel begins not with a clean genetic break, but with deep continuity and a complex mosaic already in place. In the Iron Age city of Abel Beth Makkah, a single grave offers a rare, intimate glimpse into the people who lived at the crossroads of ancient Israel, Aram, and Phoenicia. The man buried here, known to researchers as I-2201, died sometime between 1014 BCE and 836 BCE. His bones, carefully excavated from a pit on the northern edge of the city mound, still held the chemical traces of his childhood. Strontium isotope analysis of his teeth points to the basalt-rich soils of the Hula and Jezreel valleys, confirming that he grew up in the same landscape where he was laid to rest. There is no evidence he migrated from distant regions. He belonged to this place. The remains of I-2201 revealed a story written in his DNA. On his father's side, he carried the Y chromosome haplogroup TCTS 6280, a lineage with deep roots in the ancient Near East. His maternal line was marked by mitochondrial haplogroup X2b, a branch found sporadically across the Levant and Anatolia. When his genome is compared to others from the Bronze and Iron Age Levant, the pattern is unmistakable. The ancestry of I-2201 is a blend of local Neolithic farmers and migrants from the Zagros Mountains, or the Caucasus, a genetic signature that persisted through centuries of upheaval. The world I-2201 inhabited was anything but static. Abel Beth Makkah was a frontier town, shaped by shifting alliances, trade, and the ambitions of larger powers. Archaeological finds from his city include both Israelite-style pottery and imported Phoenician goods, reflecting a community at the intersection of cultures. Yet the DNA from this burial does not point to a new, sharply defined people emerging in the Iron Age. Instead, it underscores a continuity, a mosaic of ancestries that endured, even as the city's rulers and religious affiliations changed. I-2201 stands as a testament to the deep, local roots of Iron Age populations, complicating any simple story of biblical identity or ethnic boundaries. Along the southern coast of the Levant, a new chapter unfolded with the arrival of the Philistines. Archaeological layers at Ashkelon, one of their major cities, hold the genetic evidence of a migration pulse unlike anything seen in the Canaanite baseline. Ancient DNA extracted from a group of infants buried during the early Iron Age, roughly 1200 to 1000 BCE, reveals a striking pattern. Their genomes carry about 39% ancestry linked to the Aegean, a region that includes Bronze Age Greece and its islands. This European-related signal stands in sharp contrast to the local Levantine genetic background that dominated the late Bronze Age. The Y chromosome data adds another clue. Among these early Philistine children, one carried the R1b M269 lineage, a genetic marker common in Europe but previously unseen in ancient Near Eastern samples. This points to male migrants arriving from the Mediterranean, bringing with them both their genes and their cultural traditions. The archaeological record echoes this genetic influx, with Mycenaean-style pottery, new architectural forms, and burial customs appearing in Philistine settlements at the same time as the Aegean DNA. Yet this foreign imprint did not last. By the next archaeological phase, just 2 centuries later, the Philistine gene pool at Ashkelon is indistinguishable from the surrounding Levantine population. The European component vanishes, diluted through rapid intermarriage with local groups. Later Iron Age individuals from the same site show no trace of Aegean ancestry, and the R1b M269 lineage disappears from the record. The Philistine newcomers were absorbed into the local fabric with remarkable speed, leaving a cultural legacy but only a fleeting genetic signature. This episode illustrates how the ancient Levant could absorb newcomers without being fundamentally altered. The Philistine migration left a measurable mark, but it was quickly woven into the broader tapestry of the region, a region already shaped by centuries of mixing, movement, and exchange. Genome-wide surveys of Jewish populations across the world have revealed a striking pattern. Despite centuries of separation, Jews from Europe, North Africa, the Middle East, and Central Asia cluster together in genetic analyses. Principal component analysis and admixture modeling, tools that visualize genetic similarity, consistently place Ashkenazi, Sephardi, and Mizrahi Jews within a tight grouping, distinct from their non-Jewish neighbors, but overlapping with other Levantine peoples. This clustering is not an abstract mathematical result. It reflects the inheritance of DNA segments from common ancestors who once lived in the ancient Near East. Population geneticists have measured the extent of this shared ancestry in concrete terms. Studies estimate that between 30 and 60% of the genetic makeup of Ashkenazi Jews and similar or higher proportions in Sephardi and Mizrahi groups derive from Middle Eastern sources. These figures are not simply averages. They are visible in the actual segments of DNA that can be traced back to the Bronze Age and the Iron Age Levant. The remainder of the ancestry in each group reflects admixture with local populations encountered during centuries of diaspora, whether European, North African, or Persian, depending on the region. The continuity is not just in the numbers. Genetic data reveal that most Jewish populations experienced founder events, periods when a small group of ancestors gave rise to much larger communities. For Ashkenazi Jews, the timing of this founder bottleneck predates the medieval period, suggesting that the core Middle Eastern ancestry was already present before large-scale settlement in Europe. The same pattern is observed in other Jewish groups, with each community retaining a unique blend of diaspora admixture layered atop a shared Levantine core. These findings provide a measurable kinship that spans continents and centuries, connecting Jews in New York, Baghdad, Casablanca, and Tehran to a common ancestral thread. The genetic evidence aligns with historical accounts of exile, migration, and return, but it also sets a scientific baseline for evaluating later claims, such as the Khazar hypothesis, which argue for a different origin. Before entering the realm of debate, the data established that the Jewish diaspora, in all its diversity, retains a deep and persistent link to the ancient peoples of the Levant. In 2012, a genome-wide study reignited an old controversy by proposing that Ashkenazi Jews trace much of their ancestry not to the ancient Levant, but to the Khazars, a Turkic people whose medieval empire stretched across the Caucasus and southern Russia. The paper, led by Aaron Elhaik, used contemporary Armenian and Georgian populations as proxies for the Khazars and argued that the genetic signatures of Ashkenazi Jews pointed north, away from the Near East. The Khazar hypothesis, long debated on the fringes of scholarship, suddenly gained new attention, amplified in online forums and political rhetoric. But the scientific community responded with sharp scrutiny. Critics, including Doron Bahar and a team of geneticists, challenged the foundational assumptions of Elhaik's analysis. Their rebuttal, published in 2013, pointed out that using modern populations as stand-ins for a vanished medieval group introduced deep uncertainty. There are no ancient Khazar genomes, and the region's populations have shifted dramatically over the centuries. Bahar's team expanded the dataset to include over 1,200 individuals from Jewish and neighboring populations, applying a wider array of statistical models. Their findings were clear. Ashkenazi Jews consistently clustered with other Jewish groups and with Levantine populations, not with the North Caucasus or Central Asian samples meant to represent Khazars. Methodological rigor became the dividing line. The choice of reference populations, the design of admixture models, and the interpretation of QPADM results all shaped the outcome. When the same tools were applied with a broader comparative framework, the supposed Khazar signal faded into statistical noise. Peer-reviewed studies found no significant North Caucasus or Turkic ancestry in Ashkenazi Jews, at most a trace consistent with the minor gene flow seen throughout Eurasia. Instead, the dominant ancestry remained Levantine, layered with European admixture that reflects centuries of diaspora life. The debate over the Khazar hypothesis is not just academic. In the hands of political actors, it has been wielded to question the legitimacy of Jewish historical claims and to stoke division. Geneticists warn against such weaponization, emphasizing that ancestry is always more complex than any single narrative. The evidence, when weighed with scientific standards, points to a story of continuity rooted in the ancient Near East, not a wholesale replacement by medieval converts. As the field moves forward, the lesson is clear. Rigorous methods and transparent data are the best antidote to sensational claims. On the high plateaus of Ethiopia, the Beta Israel community has preserved Jewish customs for centuries. Oral histories speak of ancient ties to Israel, and religious rituals echo practices found in the Torah. Yet, when scientists conducted genome-wide studies of Beta Israel, the results challenged long-held assumptions. The DNA of Ethiopian Jews is nearly indistinguishable from their Christian and Muslim neighbors in the highlands. Both Y chromosome and mitochondrial lineages trace overwhelmingly to local East African ancestors. Only a faint signal, possibly from historic contact with the Middle East, appears in a handful of paternal lines, but it does not match the genetic patterns seen in other Jewish populations. For many in Beta Israel, these findings do not diminish their sense of belonging. Their identity is rooted in faith and tradition, not in a specific bloodline. Thousands of kilometers to the south, the Lemba people of Zimbabwe and South Africa tell a different story. Lemba oral tradition claims descent from Jewish ancestors who traveled from Sina in the north, bringing with them rituals, dietary laws, and a memory of ancient priesthood. When geneticists sampled the Lemba, they found a striking pattern in the Y chromosome data. Around 9% of Lemba men carry the Cohen modal haplotype, the same genetic signature found at high rates among Jewish priestly families. In the Buba clan, the traditional priestly lineage within the Lemba, more than half of the men possess this marker. This frequency stands out sharply against the genetic background of neighboring African groups, suggesting a limited but real paternal link to the Near East. Still, the majority of Lemba ancestry remains African, reflecting centuries of intermarriage and adaptation. These two case studies offer a caution against reducing Jewish identity to DNA alone. Beta Israel and the Lemba both maintain Jewish customs and communal memory, yet their genetic stories are profoundly different. The evidence from their genomes complicates the idea of a single, unbroken bloodline. Instead, it reveals how cultural and religious identities can persist, adapt, and even flourish across continents and through generations, regardless of the genetic threads that bind or separate them. The words Hebrew, Israelite, and Jew carry histories that reach beyond genetics or even geography. Ancient texts use these labels in ways that shift with time, politics, and religious meaning. During the Bronze and Iron Ages, the people inhabiting the southern Levant drew from a common genetic foundation, what geneticists call the Bronze Age substrate. Yet, as theologians and historians point out, biblical identities were layered and fluid, shaped as much by covenant and custom as by blood. In early biblical tradition, Hebrew often describes a social status or an outsider's perspective, a term used for Abraham and his kin, but not a fixed ethnic group. Israelite emerges later, tied to the 12 tribes said to descend from Jacob, and becomes a political and religious identity as kingdoms rise and fall. Only after the Babylonian exile, in the 6th century BCE, does the word Jew enter the historical record, referring first to the people of Judah and gradually expanding to encompass followers of the Mosaic Law, regardless of origin. Genetic studies reinforce this complexity. The Bronze Age Canaanite ancestry forms a deep common thread, but the Levant was never a closed system. Gradients of admixture, Persian, Greek, and Arabian, swept through the region with each new empire. These layers left subtle marks in the genomes of Jews, Palestinians, Lebanese, and other Levantine peoples. The boundaries between groups were porous, with religious identity often crossing genetic lines. Theologians highlight that in the biblical imagination, belonging was as much about shared law and story as about descent. This context matters when interpreting the priestly lineages or later debates about Jewish ancestry. The core genetic continuity does not map neatly onto any single biblical label. Instead, it reveals a landscape where identity was negotiated, sometimes inherited, sometimes chosen, always shaped by the currents of history and belief. A single Y chromosome signature, passed from father to son, has become a touchstone for one of Judaism's oldest traditions, the priestly lineage known as the Kohanim. Geneticists first identified the so-called Cohen modal haplotype, also called CMH, in the late 1990s, noting its striking enrichment among self-identified Jewish priests across Ashkenazi, Sephardi, and Mizrahi communities. In published surveys, between 45 and 69% of Kohanim carry this cluster of Y chromosome markers, a proportion far exceeding that seen in the broader Jewish population. By tracing the subtle changes that accumulate in these markers over generations, researchers estimated that the common ancestor of most living Kohanim lived between 2,100 to 3,250 years ago. This time frame aligns with the biblical tradition of a priesthood descending from Aaron, brother of Moses, but the genetic story is more complicated than a direct line from scripture to present. Population geneticists highlight that the CMH is not exclusive to Jewish priests. Variants of this Y signature appear at lower frequency among other Levantine populations, including Druze, Palestinians, and some Syrians, reflecting the deep, shared ancestry of the region. The CMH itself falls within broader haplogroups J1 and J2, lineages that have roots in the ancient Near East and were already present in Bronze and Iron Age genomes from the Levant. This means the priestly marker is not a unique genetic stamp, but rather a branch pruned and preserved by tradition and endogamy. The story of the CMH illustrates both the power and the limits of genetic genealogy. On one hand, it provides rare molecular evidence for a patrilineal tradition stretching back millennia. On the other, it underscores how a single lineage can become prominent within a group through founder effects and social structure, rather than by representing a distinct or isolated population. The priestly Y signal, then, is best understood as a thread woven through the larger tapestry of Levantine ancestry, a marker of memory as much as of biology. Genetic evidence unsettles rigid narratives, revealing a legacy shaped by migration, memory, and covenant as much as by shared DNA. Today, debates over identity remain fiercely contested, often echoing far beyond science or scripture. The question endures: whose story gets to define belonging? In a world divided by ancestry claims, humility before the evidence is not just wise, it's necessary. Share your perspective below.